I bet you weren't expecting to see this again for a while, but it looks like we're going for take whatever it is with this Sansui 907MR. I thought I covered everything off in this amplifier, but I'm starting to learn some new things since I got my audio analyzer, and this amplifier unfortunately has become a little bit of a problem for me. So, in my infinite wisdom, I decided, hey, let's put this flagship Sansui on the audio analyzer and see how much distortion it's creating and does it meet its specification. Long story short, it does not meet its specification. The distortion is inconsistent. It is quite a bit. It was going from like 0.2% up over 1% and dropping down. I could never hear anything wrong with this. The distortion is low enough that you wouldn't really hear it, but for a flagship amplifier, it isn't good enough. So I did a bit of work. I didn't record any of this, obviously, but I found out that the speaker protection relay is bad. It's inconsistent, and if you tap on the chassis, you get the distortion to sort of just jump around. I know we cleaned the relay, but obviously it was not good enough, and I've never had an audio analyzer before to be able to verify how good a speaker protection relay is after you clean it. As it turns out, probably not very good. So we are replacing the protection relay with a new Omron unit made in China. Ugh, unfortunately. I have a spare relay here as well. I just, whenever I need something, I usually order a spare in case I have to do another one. So we have to undo this thing again. We have to go back to the protection board, pull out the speaker relay, replace it. Spoiler alert, I have already been in there and had a look at this relay and confirmed it is the problem. But I had to order the part and put it all back together. So now we're going to take it apart again. And I'm also going to have a look at this record out selector, because I've noticed that that is creating a little bit of crackling also. That is a cable switch which goes all the way to the back in the input board, which is not going to be fun, I don't think. We might have a look at this input selector section as well. We'll see what happens once I get this thing apart. So yeah, let's get started and rip this thing open. Alrighty, relay is out. There is the part number if anyone needs to know what this relay is without having to remove the whole thing and peel all this bitumen off, which was a pain in the butt. The replacement relay looks like we did well. Looks like a direct drop-in replacement. So I'm going to throw this in, reverse what I just did on video, and then we're going to start having a look at that input board, I think. All right, the input board is up. This is the switch I need to get to. Oh, this is crap. I hate these things. So basically you can unclip this white portion with a flat blade, and then you've got to remove this entire metal sled, which requires desoldering all those pins there. You've got to be careful not to damage this ribbon. If it gets dented, it doesn't move properly. So I'm going to try to get this out, but I'll probably only be able to film this unsoldering section because this is not great. I should probably do this switch as well, but I really don't want to. That's the moving magnet, moving coil switch, I think. Yeah, this sucks. This part, I don't like it. All right, so got the switch assembly out. All I've done at the moment is opened up these little claws just to make sure I can actually do it. You need some really good pliers to grab these because they are incredibly strong. Normally they're quite easy to bend, but these ones really put up a fight. Sorry, I'm just trying to make sure I stay in frame here. So the sled usually just pulls out the bottom, but this switch is a little bit different to what I have normally seen. Don't take that out with it, please. Ooh. So, yeah, these are the little fingers that move across. It's the same deal as those little ones that we did on the front panel in one of the other videos. And there's a lot of corrosion here. Holy moly. I'm assuming these are silver plated because that looks like tarnishing from silver. Oh, and it's sort of rubbing off as well. That's interesting. These are keyed also, so you can screw this up by the looks of it. If you are not careful, these need to go back in the same way. Oh, please don't come out, Mr. Sled. Stay in there. Yeah, so the little leg has to go to the right. And I've got to put all this back together. So I'm going to try and concentrate on this. I will keep filming. And just see how we go. I really need to pay attention to what I'm doing here to make sure I don't put something in backwards. All right, I think this cleaned up pretty well. All the plates look really good, and it doesn't look like I took any of the plating or coating off them. I just ended up using like a brush, a light brush to clean the surface. Gone over it with alcohol many times, and a lot of crap came out of these plates. The fingers are still soaking in toluene. I decided to step it up because I cannot clean these directly and I don't want any film left behind on them. So they're just going to sit in that till they're ready to go back on. I'm going to put a layer of deoxide gold on these plates, put the fingers back on, and then reassemble this thing, hopefully, in a way that it is going to work again. All right, one other thing I'll show you before I throw this switch in. These little claws that hold the PCB in, were incredibly hard to push back down. I ended up having to use a vise with a pin to drive them down. I had to get them started, get them on a bit of an angle, and then basically press them back in. And it went pretty well. I don't recommend trying to use pliers to bend these back over because I kept knocking the pins and I could just see one of these getting close to snapping off. So be very, very careful if you decide to take one of these things apart. This metal plate is very robust and very hard to bend these little claws. So I'm going to throw this back in and then see what else we can do. All right, so I've dropped down the front panel. Pretty good access, surprisingly. Plenty of loose cable to work with. So I don't even know the condition of this switch gear, and I'm going to just take this one step at a time because there's nothing really wrong with these switches, these other ones anyway. And I may not even need to take them apart, but I thought, look, we've got this thing apart again. I may as well at least have a look at one of these switches. So I'm going to take the power amp direct operation switch out and we'll have a look. I've decided, because these are all PCB mounted, I will drop the switch out, I'll desolder the switch from the PCB and leave the PCB in there because keeping track of all the wires is a lot harder than just desoldering the switch from the PCB. I would also like to have a look at the input selector switch, but we'll just take this one step at a time. And there are two more of those slidey switches down there. And there's also this giant pot as well, but if I mess with the pot, I've got to peel all the bitumen off, and if I take the bitumen off, then I don't have anything to put back in its place, so it won't be original anymore, I guess. Anyway, I'm going to get this switch out, and we'll have a look and see what we're dealing with. So if you're wondering why many technicians don't take switchgear apart to clean it as part of a normal amplifier restoration, this should be giving you some idea of why. This single switch probably took me an hour-ish and you have to be incredibly careful because if you break one of these things, you're done. Anyway, this one's all clean. I'm decided I'm going to keep going after seeing the condition of this. I'm going to pull out some other ones. The only tricky thing I noticed with this particular switch is that you need to sort of peen over these little retention clips very, very gently, trying not to hit these other pins. And you've got to press them all back out again so this thing is back to original condition. A lot of very tedious, careful work to take these things apart rather than just spray some deoxit in them and hope they work. Not to mention desoldering and all the other stuff you've got to do. So yeah, if you are wondering why your audio techs who do the job properly charge so much money, this is why. Alright, so the power amp direct switch is back in. I've just removed the input selection switch. I'm going to do this one off camera because it is exactly the same as the other one. And then I think we're going to try and do these two bottom ones. And I'm not sure about this volume pot yet. I'm still thinking about it, but I'll get this one done. So I've decided I'm going to at least have a look at this volume pot. So I'm going to remove it and see what I'm getting myself into. As far as I know, these have a star lock washer on the back of them that's single use and has to be replaced. So I've got to take care of that. All the other switchgear is done. It was basically the same process as doing the first one, so I didn't bother filming it again and again and again. But there was a switch here. Here, there were two down the bottom. They're all done. I think I'm going to leave whatever else is in that area. But I'm going to desolder this volume pot now, and we'll see what we're getting ourselves into. Alright, so I got the pot apart, finally figured out how to get the rear cover off, and unfortunately this does have a star lock, which I knew was a thing, but I didn't know what size it was, so I ordered a set, and unfortunately the smallest size you can easily get is M3 in Australia, probably in most places I would say, and this is about a 2.5 millimeter star lock by the looks of it, and you pretty much have to cut these off. If you pry on this, you're going to damage the plate underneath it most likely, or warp the fingers underneath, so I wouldn't recommend doing that. So I just sprayed some Fader Lube in there and just cleaning it up while it's apart and off the board so I can clean all the residue and just give it a bit of a soak. Not ideal, I would rather take it apart, but we're just going to have to leave it for the time being and come back to it one day. So I'm going to get the amp reassembled and let's see if the distortion measurements are good. Alright, she's all back together. Just been doing some testing at a low power, just 1 watt, just running through all the controls, cycling everything, just making sure there's no issues with any of the switchgear, and we're looking really good. I'll overlay some limited results I did where I ran it up to about half power. I can't really go any further than that. I am only supposed to go up to 30 volts when I'm floating the analyzer. I did try exceeding that, which I know I shouldn't do, and the distortion just sort of went up. And I don't think there's an issue with this. I think it's just the analyzer and I'm doing something I just shouldn't be doing. Got to be really careful with these amps. There's a lot of gotchas because the positive and negative, but in this case hot and cold side, are both live in their own way. You cannot ground it in any way. You can't join it together. You can't do anything. So I can't hook a scope up. I have to keep the ground floated. And also someone pointed out to me, which thank you for that, because I almost did damage to the amplifier. I had both channels plugged in at the same time. Can't do that either, because even though it's floating, the channels are connected on the low ground side, whatever you want to call it. And it was basically joining the two channels together on the cold side, which is very bad. And all I could see was a lot of distortion on the analyzer, and it wasn't making a lot of sense. But now I know. Another thing I've learnt, and I've got to be very careful of in the future if I ever mess with another amplifier design like this. So yeah, I'm bringing this thing back inside. This is supposed to be my amplifier that I just enjoy and don't screw with, and it may make future appearances, who knows. But yes, I will see you in the next video.